Hello learner, my name is Dickens and we are looking at methods of preparing salts, and in today's lesson we are going to look at how to prepare salts by reaction between an acid and a metal oxide. That is what I want us to look at in this lesson. Reaction between an acid and metal oxide. That is what I want us to look at in today's lesson. So we are going to consider a brief experiment here. We are going to look at experiment. We are going to look at preparation of copper to sulfate. Preparation of copper to sulfate. That will be our basis of today's discussion. So our procedure is as follows. You measure about 20 centimeters cubed of dilute sulfuric acid and transfer into a beaker. So of course we measure using a measuring cylinder, and then after that you warm the acid just for a few minutes. So the reason why you're warming the acid is simply to increase the rate of reaction. Remember, we are reacting an acid and a metal oxide. Therefore, when the acid is cold, the reaction will be very slow. So we warm the acid so that we can increase the rate of reaction. Secondly, procedure: you add copper to oxide to the warm acid. We are adding copper to oxide to the warm acid, a little at a time. As you stir. Of course, we are stirring with a glass rod so that we can increase the contact between the reactants. Remember, our reactants are the sulfuric acid and copper to oxide. So we stir so that we can increase that area of contact. Thirdly, continue adding copper to oxide until in excess. So we shall add more and more copper oxide as we stir until it is in excess. So we can realize that we are using excess copper oxide to make sure that all the acid has been used up. Fourthly, you filter to remove excess copper oxide. So remember, when you carry out filtration, we shall obtain a filtrate. And remember, the filtrate is obtained as a result of the reaction between copper to oxide and sulfuric acid. So in essence, our filtrate will be copper to sulfate. So that is what we shall get after carrying out filtration. So lastly, after filtering, you evaporate the filtrate. Over a water bath. So we are using a water bath to simply slow down the process of evaporation over a water bath. So that we can slow down the process of evaporation, and that will help us in obtaining large crystals. So Having talked about the procedure, let us look at now the reactions that are involved here. The main reaction, we look at the discussion, we call it discussion, or the observations. So we are reacting copper oxide with sulfuric acid. This will be the expected reaction. Copper oxide will react with sulfuric acid. Remember, it is dilute. Copper oxide is a solid. So the two compounds react. We shall get two products. We shall get a salt and water. So the name of the salt will be copper sulfate, which will be in solution form. That's why we are carrying out filtration, and water. So we shall get two products. You'll get copper sulfate and water. And remember, we said anytime you write an equation, you should make sure that you have balanced the equation, and you balance by making sure that the atoms of each kind are equal on both sides of the equation. So we check copper atoms. This is one on the left and one on the right hand side, so copper is balanced. You also check oxygen atoms. This is 1 plus 4, those are 5. Check oxygen atoms on the right hand side. This is 4 plus 1, that is 5, meaning oxygen atoms are balanced. Next, you check hydrogen atoms. These are 2 on the left. We also have 2 on the right. That means hydrogen atoms is balanced. Now you come to sulfur. Sulfur, this is 1 atom, this is also 1. So it means the whole equation is balanced. So this equation is as a result of reaction between a metal oxide, which is copper oxide, and sulfuric acid. That will give you copper sulfate and water. So it's also good we mention other salts which can be prepared using the same method. Other salts prepared by the same method include the following. Same method include, there are quite a number. We are just going to mention a few for the sake of writing the chemical equations. We can have zinc sulfate. Zinc sulfate can be produced in a similar method. We can have magnesium nitrate. Magnesium nitrate can also be produced by the same method. We can have calcium chloride. It can be produced using the same method of reaction between an acid and a metal oxide. We can still have more like sodium chloride. Maybe one more. We can have zinc nitrate. So these are just some of the salts which can be produced using this method of reaction between an acid and a metal oxide. So in terms of the reactions, this is how these salts are produced. We start by zinc sulfate. From the name, it means we're reacting zinc oxide with sulfuric acid. So this is the reaction. So these are the reactions. The reactions are as follows. So the first one, we are reacting zinc oxide with sulfuric acid. Zinc oxide reacts with sulfuric acid. Remember, sulfuric acid is dilute. So we put aqueous, we shall get a salt. And that salt is called zinc sulfate plus water. So we get two products. You can balance. If you check, it's already balanced. The other salt is magnesium nitrate. From the name nitrate, it means we are having nitric acid being one of the reagents. So we are saying that magnesium oxide will react with nitric acid, and then the product will be magnesium nitrate. When you're writing the formula, you should be careful with the valencies and water. So let us check if it is balanced. Magnesium atom is 1 on the left, 1 on the right. Check oxygen atoms, 1 on the left plus these are 4. This side has 3 times 2, that is 6. You add 1, 7. So that means oxygen atoms are not balanced. Come to hydrogen. This side has 1 atom. This side has 2 atoms. Come to nitrogen. This side has 1. This side has 2. So the easiest way of balancing is if you put 2 on nitric acid, it will mean I'll have 2 atoms of a hydrogen on the left and 2 atoms of hydrogen on the left. What about hydrogen atoms? This will be 2 times 3. This is 6 plus 1, 7. 3 times 2, 6 plus 1, 7. That means we have balanced the atoms of oxygen. The next one is calcium oxide. Remember, we are looking at how the salts are formed by the reaction between an acid and a metal oxide. So how can we form calcium chloride? So from the name chloride, it means we are using hydrochloric acid. So this will be the reaction. It's going to be calcium oxide reacting with HCl, the other name, hydrochloric acid. Don't forget to put the state symbols. This one is solid, this one is aqueous. So this will give you a salt, and that salt is called calcium chloride. It's aqueous, and then plus water. After writing, don't forget to balance. We put 2 on hydrochloric acid, then the equation will be balanced. The other salt is sodium chloride. We can obtain sodium chloride by reaction between sodium oxide and hydrochloric acid. This will still give you a sodium chloride. So the reaction takes place. We get sodium chloride and water. So we check if it is balanced. You can see we have 2 atoms of sodium on the left hand side. The right hand side has 1. So we have to balance by putting 2 on sodium chloride. That will mean I will have 2 atoms of sodium on the right and 2 on the left. That calls us to also check whether I'm having equal atoms of chlorine also on the left and on the right. Chlorine atoms is 1 on the left. This side has 2, so I have to balance. I multiply this one by 2 like that. So that will mean that I will have 2 chlorine atoms on the left as well as 2 hydrogen atoms on the left. Remember, the right hand side also has 2 hydrogen atoms, so the equation is balanced. Maybe one more. Formation of zinc nitrate. We need to know that zinc nitrate is formed from nitric acid. That means we are reacting zinc oxide with nitric acid. As we can see there, our salt will be called zinc nitrate. Should be careful with the valencies and water, and then you balance the way we have seen earlier. You balance, you put here 2, the equation will be balanced. So we are saying this, learn that salts can be prepared by reaction between a metal oxide and an acid. That will give you 2 products. You'll get a salt and hydrogen gas. So having said that, I want you to try these questions during your own free time. Try these questions. they'll be good for you. So our first question is state why excess copper oxide was used during the reaction, during the experiment. State why excess copper oxide was used during the experiment. Question number 2 is give a reason why the acid was warmed first. Give a reason why the acid was warmed first. And then lastly is write balanced chemical equations for the following reactions. For these reactions, write balanced chemical equation for these reactions. So the first reaction is between zinc oxide and sulfuric acid. You try that one, get the products. We are still reacting a metal oxide and an acid. The second one is try and write the reaction between magnesium oxide and hydrochloric acid. So you'd still get a salt and water. So we have just looked at how to prepare salts by reacting an acid and a metal oxide. I want us to look at another method of preparing salts. This time around, we are looking at the reaction between an acid and a metal hydroxide. So that is the one I want us to look at. So we are looking at reaction between an acid and metal hydroxide. Remember we said both metal oxide and metal hydroxide are regarded as bases. Don't forget that. So I want us to consider a very simple experiment here. Preparation of sodium chloride. Let us consider that one for this particular discussion. So let's look at the procedure briefly. The first thing you do, remember we want to prepare sodium chloride, and we're learning about reaction between an acid and a metal hydroxide. So you should be able to know the reagents that we need here. So procedure number 1 is measure about 25 centimeters cubed. Measure about 25 centimeters cubed of sodium hydroxide solution and transfer into a beaker. So I believe you can do it. You just measure using a measuring cylinder, 25 cubic centimeters. Secondly, after doing that, you add 2 or 3 drops of phenolphthalein indicator. In Form 1, we learned about indicators, and one of them was phenolphthalein. So you should be able to tell the color of this solution when I add phenolphthalein indicator. So phenolphthalein indicator we are adding in a basic solution. We expect the color to be pink. So when I add 2 or 3 drops of phenolphthalein here, I'm supposed to have the solution being pink in color. We shall see the main use of the indicator in a moment. Thirdly, you add about you add about 25 centimeters cubed of hydrochloric acid to the solution until the pink color disappears. So the disappearance of the pink color will be an indicator that the reaction is over. Remember, we are having a reaction between hydrochloric acid and sodium hydroxide. So we are using an indicator, and this indicator will be used to show the end point. So the indicator here will be used to show the end point, and the end point simply means the point at which all the acid has been completely neutralized. That's the main use of the indicator. Okay, fourth point, transfer about 25 centimeters cubed of the resulting solution into an evaporating dish. Now remember, the resulting solution is the product of the reaction between hydrochloric acid and sodium hydroxide. So when hydrochloric acid reacts with the sodium hydroxide, we shall get a salt, and that salt is called sodium chloride. So we are going to have two products. We shall have sodium chloride and water. So that sodium chloride is the one that we shall now put into an evaporating dish. Remember, we want to obtain solid sodium chloride. Therefore, we have to carry out evaporation. So you put it on an evaporating dish. Lastly, evaporate the solution. Evaporate the solution until it is about to form crystals. So how do you tell? It's about to form crystals? We say you take a clean glass rod and then you dip into that solution that you are evaporating, and then you hold it in the air. You allow need to cool down, after which you will observe the crystals. The crystals will be seen on the glass rod. That will mean the solution is ready to form crystals. Then after that, you allow it to cool. So that is the brief experiment. Let's look at the discussion, the expected observations. Discussion. So remember, we are reacting an acid and a metal hydroxide. So for this particular experiment, the reaction was between sodium hydroxide and hydrochloric acid. So this will be the reaction. Sodium hydroxide reacts with hydrochloric acid, and that will give you sodium chloride plus water liquid. So this one is aqueous, this one is also aqueous, this one is also aqueous. So we are saying metal hydroxide plus an acid, you get a salt and water. Other salts prepared by the same method same method. Other salts prepared by the same method include. So we have quite a number. We're just going to mention a few of them. We have salts like magnesium chloride. We have salts like sodium sulfate. We have salts like potassium nitrate, etc. So let us see how are they prepared using equations. So these are the reactions that will take place in this one. So magnesium chloride is a product of reaction between magnesium hydroxide and hydrochloric acid. Remember what we are handling? Metal hydroxide and an acid. So this will be the reaction. Magnesium hydroxide aqueous reacting with hydrochloric acid, and that will give you magnesium chloride and water. You check if the equation is balanced. Of course, we have one atom of magnesium on both sides. It's okay. Come to oxygen. We have 2 atoms of oxygen on the left and 1 on the right. That means oxygen atoms are not balanced. Come to hydrogen. This one has 2 plus 1, 3. This side has 2. So it's not balanced. So we have to start by balancing the hydrogen atoms. We want to make this side to have even. So we shall put here 2 so that I'll have 4 atoms of hydrogen. Then I put here 2 so that I'll have 4 atoms of hydrogen. And by so doing, we shall have balanced our equation. Next, sodium sulfate. Sodium sulfate, remember, metal hydroxide and an acid. So sodium sulfate is coming from sulfuric acid. So we are reacting sulfuric acid and sodium hydroxide. So this would be the reaction. Sulfuric acid plus sodium hydroxide. What will be the products? The products will be a sodium sulfate aqueous plus water. Don't forget to balance. We put 2 here, then we shall have balanced the equation. Maybe lastly this one, nitric acid. We are reacting nitric acid with the potassium hydroxide, which will get potassium nitrate. So nitric acid reacting with potassium hydroxide, that will give you potassium nitrate aqueous plus water. That will be our other product. If you check keenly, the equation is balanced. So learner, we have come to the end of our lesson. Remember, we have learned method number 3 of preparing salts, which involves the reaction between an acid and a metal hydroxide. We have said the acid reacts with the metal hydroxide to form a salt and water. So I want you to try these questions. Try these questions during your free time. So the first question is, you are supposed to define the word endpoint. Remember, we have mentioned somewhere the word endpoint, and this comes in when we are handling an indicator. So define the word endpoint, and then secondly, write balanced chemical equations. Write balanced chemical equations for the following reactions. following reactions. The first one is ammonium hydroxide plus sulfuric acid. Get the products. The next one is magnesium hydroxide plus nitric acid. Maybe one more is zinc hydroxide reacting with hydrochloric acid. Try and write those equations. They just give you a summary on what you have learned today, that we can prepare salts by reacting a metal hydroxide and an acid. So that's the end of our lesson for today. I want to thank you for being a good student. I'll see you in our next lesson.